Good afternoon. This is Bart Soede at SARC. I'm going to present you some new stuff on Fairway. New stuff that is things that we have already been getting used to over the past time, but not everybody of our viewers have Fairway, and some of you will not have seen the latest updates yet. So we have put in quite a lot of work on the interface of Fairway, which I will show in a brief moment. If I can switch off the camera and well, you've seen me enough for now. I'll be the host of your webinar for the rest. So I will now switch to Fairway. I'm going to do all presentations live, so this will be recorded during the session. We have three topics for now. One is the current interface of Fairway, the looks and feel of that. One is modeling in Fairway, so defining the basic shape for a new vessel, or part of that anyway. And the third part will be some export functions, which were cumbersome for some programs in the past, and we have made a huge step, and I want to show that because that has been, we hear that as an argument against Fairway, but that's a solved issue basically. So from the top down, I will start showing you the interface of Fairway. So I will kill the webcam, and if everything is okay, you should still be able to see my screen. The interface of Fairway. Fairway starts here from the main menu of Pius, and this is the not so graphical first screen that we get, and from the graphical user interface that will open now, here you have it. This is a model I'll be using later for some further stuff, but to show you something on the graphical interface, basically all commands that we frequently use will have their icon here, and you can drop them as you would expect from a current CAD-like system or design system in this case. They all have their specific toolbars which we can switch on or off. Toolbars there I can do with or without them, whatever I please. So if you miss one of the toolbars, just look under Window and Toolbars, you'll be able to open them. Of course we have a 3D model, so we can rotate it. Left mouse button, the right mouse button will switch from perspective projection. You see some other options which are saved for SARC rather than for others. Depending on the view you prefer, you can play tricks with that. You can render the whole, there's a tree view here with all the parts of the shell, so I can make the shell invisible, so nothing has changed on the model. I'm just not rendering the actual shell, only the curves we do manipulation on. More about that later. We can play with different objects and move, scale, rotate them, etc. I will be discussing those further on, but we've tried to organize commands per category basically. So you can have your object commands here. So check a solid, some checks on the consistency of the solid will be carried out if you have a solid, or if you do not have a solid yet, you're yet working with a wireframe model that you've imported, or otherwise these will be no longer grayed out, but actually you'll be able to use them. Polycurves, any curve you see here can be manipulated through the polycurves or the associated toolbar. So new planet polycurve by intersection, I'll be showing that later, is the same command as here. If I hover the mouse over it, you will see the same command popping up. So you have a choice either to use the pop-down menus, the pull-down menus, or the toolbars. Properties of curves, that will have an icon later on, and move polycurve also. So some of them do not have an icon, which is a slight inconsistency that will be solved anytime soon. The shell, you can play tricks with that. I'll be showing that a bit in a further session, as part of this webinar actually. The display options, so design dimensions, you can see here in gray lines the designated main dimensions. So for width, apparently somebody scaled the width up or did wrong input because, well, no, that's the length, height, the length, the waterline, and the width, but the width is not really displayed here, so there must be some input error there. In display, construction waterline, and that is visible here in, well, grayish color. If I switch on rendering again, it will be better visible. There you can see it's the gray part is the waterline, well, for the as defined in the main sections. So that's on the new interface in Fairway. Some people that have used Fairway, I don't know, 10 years back or so, will hardly recognize what we've done to it, and others that have stepped into the new Fairway, the not so DOSy Fairway actually, at a later stage may find it very helpful that we have defined all these icons to do specific tasks. There's been quite a lot of work, but we are proud to share that with anyone who hasn't seen it yet. Then the tree view, which is very handy. All, well, parts of the model can be found here. So if I open this waterline, that spline, I can right click and step into manipulation of that particular curve, as if I would have selected the same command. So we have two-way traffic basically. I can either select a curve for manipulation. Where did I put my there, curve manipulation, and then select the curve, or do it vice versa to the same effect. Of course, if I would have changed something to the model, I can store the data. Well, let's do so. I will insert a point that will not affect the apply, and then save the whole thing again, and well, there you have it. So most manipulation of stuff is included in the GUI now, and well, we're proud of that. It makes our life easier because it's easier to teach people how to work with Fairway, and it will surely make the user's life, the Fairway user's life, a bit easier because, well, everything can be found under these buttons. That's it on the new interface of Fairway. Some things will yet move or possibly included in one of these toolbars that is currently listed in the text menu, the start menu of Fairway, but that will be, well, issued later, and we will comment on that later on in our news section, so please check it out later on. Okay, that's on the graphical user interface of Fairway. Then, I've done this a few times earlier. We will create a new file live, so I'm going to define a demo build form. As said, this is live, so I'm taking a bit of a risk here because, well, the strong thing is that I do this, well, prepared in the sense that, sorry, Fairway, took the wrong button there. I'm unprepared as I do have an idea in my head, but I didn't prepare any shape or sketches of that, so this is all from experience. We will start with a new hull design. I will give it some characteristics. Demo, length 95 meters, making this up as we go along. The breadth, that's a bit less, 12 meters, molded draft 6, and molded depth 8. These are target values, but I don't need to fill them in order to reach a, well, some specific value. I'll show you that later. Graphical user interface, you've seen it already, but now I'm going to comment on what I'm doing as I'm defining a model. Well, this is like a banana peel of a model. I will first kill the main dimensions and the construction waterline because I'm only interested in the shape of the thing itself, not in the main dimensions, because I can change them at any time and scale up the vessel accordingly if so required. So this is like a banana peel, and if I would render the shell and do rendering a bit there, detailed surface mesh. Now the surface patches were very small. If I create 1 meter, show all shells there, then the rendering is a bit better. But, well, it's not a nice vessel yet. I will not show you the rendering because we are manipulating curves in Fairway or polycurves. I will show you the difference in a moment. That will start basically now. I will include a new polycurve by interpolation, a waterline. This will be the start of the flat bottom. If I'm going to interpolate a waterline on 1 meter. If I would do that at 0 meters for the flat bottom, it would only intersect the current model at this one point, which would be pretty much useless. So I will interpolate it, I will call it flat bottom, apply it, and now we have a curve that will be the start of my flat bottom. I need to manipulate that, so I can select it here, right mouse click, move this curve. It's now on 1 and now it's on 0 meters, so at least it's on the proper height. I can just move a curve through this graphical interface there, and now we have something to start manipulating on. But I want to do the same with the flat side, and a brief comment here. You will see that this curve, it's now in move mode, so the move function is still active. But if I were to select this curve, this is the representation of the curve that we already had, the frame, and because of the moving of this particular waterline, waterline 0, the frame has shaped accordingly. So the point on this frame has been dragged down to this 1 meter in accordance with the waterline position. This is an intersection point. I can do quite a few things with it, but I cannot delete it because the intersection between curves are the consistency in our model. We cannot go from one part of the vessel to another part of the vessel without crossing several curves, and a crossing of a curve would imply a intersection point. But back to defining a further curve. So the buttock, what's the width for? I made it, the width was 12 meters, so if I would do this at 5, it would be 1 meter off the half breadth. Apply and close. Well, here we have the start of our flat side, and I will do the same there with the polycurve. Move polycurve, that's the one that didn't have an icon, so that needs to go either through the menu or through the tree view. Apply. So we have the start of a flat side and a flat bottom, but of course they are anything but flat. So what do we need? This is now a curve, a single curve that I can manipulate, and I want to insert knuckles. That is, I want to make sure that the flat side will indeed be flat, and towards the bow the thing may be curved. So I need a discontinuity here, which we call a knuckle. So by selecting the knuckle function and clicking on the proper point, on the proper intersection point, we can, or an intermediate point, I will explain that later, you can make sure that the knuckles are in the proper place. So this is now the frame with 2, well, hard knuckles in it. That's not how we want to keep it. I will show that later. This model, well, it's starting to look right, but it's not. Because if I would introduce a further frame, this is the frame at half length, but let's pick 50 meters, so just a little bit ahead, and I interpolate that, it doesn't have a knuckle, neither here nor there, so that's not good. I will undo this particular command. I need to drop them in the right place because I'm confusing myself over this. There we go. At least I think these are the proper places, but you're free to choose otherwise, of course. So what I'm going to do, the polycurve properties, which are the properties of polycurves, I'm looking for them. Yeah, I typically do that from the toolbars, but well, for the demo I'm trying not to make things a bit more understandable for you. I can select multiple curves and make them a chine. You will see the two things. They will be drawn thicker, so that is the indication that it's either a regular curve or a chine, and it will have a dramatic effect on the further curves to be interpolated there. The same frame as before on 50 meters, not 500, 50. Indeed has 2 hard chines there. So it's a property of this curve that a curve crossing it on interpolation will already have two hard knuckles there. We'll undo that because I don't need that curve for now. Okay, we're going to start dragging around a bit. Curve manipulation. Most of the design is done by polycurve and curve manipulation. The difference is, polycurve, this is a polycurve, anything selected in yellow if I put my cursor over it, and curve manipulation, which I'm about to do now, this one is selected. So a curve is part of a polycurve and they are separated by knuckles. Of course, a curve can be the same as the polycurve if it has no knuckles. Then you have a polycurve consisting of one curve, but typically, or well, in many cases, you would have more curves connected through knuckles being part of the same polycurve. We try to use that because in lines modeling and nerves modeling, etc., terminology is rather difficult, and it just helps if you're talking about the same stuff consistently. The deckline. Well, we can play tricks with our curves. This curve, yeah, I want my deckline here from bow to flat side to be faired onto the flat side, and that's an easy one. So you can see the little dots moving here in the direction. So this is the start of this curve, that is the end, and at the start I want to give it a slave tangent, and that means that the direction on this side of the knuckle is derived from the direction of the other side. And that's a, let's say, a dynamic connection. So if I change this part here, I can insert, oh, that's a curve, I was looking for a point, insert a point, drag. If I move the deckline there, then the deckline towards the bow will follow. So this will show you that here on the aft end we did not create a slave dependency for the tangent, but on the forehand we did. So if I drag this around, you will see the deckline forward moving with the tangent as defined by its neighbor. We said we don't need that for now, but this is already better looking than it did before. So I will do the same thing here. The curve manipulation, I will get back to that later. Yeah, I will skip this for now. We will not inserting a vertex. I will discuss vertex in a moment. But this will be a curve with a slave tangent as well at the beginning. So it's already starting to look like a bow. Well, sort of. But the point, I will drag this point, and by just clicking, right mouse click this was, and you can see the shortcuts light up here. So D is a shortcut within this menu for drag, or if I press K it would be a knuckle. Waiting, I will discuss those briefly if we get that far in a few moments. So now we will drag this curve up front, and you can see that the tangent is, well, consistently is kept consistent here with the new position, and the waterline follows, and the flat bottom line, the center line follows, because they're all connected to the single point that I'm manipulating. So a bit more of that. Yeah, you can see here on the right hand side the corresponding coordinates following, and I have a direct access to the height of the deck. If I want to keep it 8 meters, or if I want to raise it to 8.5, at that point I can. And if I do that, it seems logical to raise it a little more here. I can just raise it to 9 meters, and still the tangent dependency would be kept. Of course, my frame here is not likely to have two hard chines, so it will be a slave tangent and a circular arc there. And by simply defining the proper positions here, the points, well, the width, no, sorry, the breadth of this one, yeah, width, breadth, same thing. If we put that, if we define that to be 5 meters, apply, and, well, or in the curve itself, I changed the curve breadth of the waterline before, but I could have done the same in the frame because they are the same points. And this point I can select it here and with the F2 button drop directly on the one of the three coordinates there. And if I would drop that at 1, then we have defined our, well, midship frame basically. And of course, we need to put that in the right place because this will likely not be the end of the parallel midship. So let's move this curve. Where are you? There. The polycurve. Oh, this is properties. Sorry. Move the project polycurve. That's not the one. Where did I move? Oh, that's the one I keep forgetting that didn't have an icon yet. Here it's at 47, so let's drop it at 60 meters, well, a bit further forward. 70, whoa, not 670, but just 70. 70 should be good. Apply, you can see a strange phenomenon here. These curves seem to, well, cross each other. In fact, they do in our model, but not to worry, we can quickly correct that by defining the proper knuckles again. A knuckle here and a knuckle there. So we have the start of our midship section, but of course the end is still rubbish. Polycurves, a new polycurve intersection, a frame for the aft end. I don't know, 20 meters. That's not enough, so we can drag it to approximately the right place. I can now see it will intersect this plane there. So let's use rounded off measurements, apply, and we can do the same thing with this curve. Breadth will be 5, the height there will be 6, and is that correct? No, the height will be 1, of course. Apply, and of course the same thing happens here, so I need to define knuckles for the. It may look a bit confusing in the beginning, but trust me on this, that will be solved quite easily. Now you can see here that the deck line is actually a bit, well, has become curved as well. So here we are at 8.5, there we are still at 8 meters, and this, because the deck line is running smoothly through these curves, has sagged a little there. So what I'm going to do, I'm going to create a knuckle here, and that should be 8 meters, yet it is, and I can draw a straight line there. So this is now a straight line, and all the points in between will be amended, and they will also have their proper heights. Apply, and now here, this particular curve is not yet slave dependent of its neighbor, so they're slave dependent, and you can see that the forward part will follow again. Of course, the direction of this curve will still determine what happens next to its neighbor. I'm not happy with the position of this one yet, so polycurves, move this polycurve a bit further, 75, that's better. Apply, and that's better because I'm going to, well, manipulate some more. Here, points, insert point, create knuckle, drag it around a little bit, so, and insert another point, drag it, and let's drag this one out. This curve is interesting, or, well, not surprising. It's connected to both a center line and to the waterline, so I can only move it in one direction. And you can see a little arrow here which indicates that direction. For a 3D curve like this one, I can move it about in any direction, but any curve will remain in the plane of its any point will remain in the plane of its associated curve. And if there are two, we only have 1 degree of freedom. If we have 3 different types of curves running through the same point, it will be, well, fixed. You cannot move it in any direction, which is consistent, of course. Then you may want to delete one of these curves or change curve type, something like that. Then the flat bottom, typically you would have a slave tangent here and a slave tangent to the flat side. There, starting to look like, well, it could be a vessel. I don't particularly like the position here because it may be formally correct, it's just not looking nice. So drag this one. Width is still correct, and yeah, perhaps I should focus a little bit on this one. Move this up and apply, and then select this one. I want my curve there to start completely sideways. So the manual tangent, 0 length, breadth, and 0 height difference. So it will start horizontally at center line, and now this curve should look, well, a bit more like you would expect of a deck line, and it would even look nice. If I select a curve here, I can select the curvature of that curve, and in this case also of the crossing curve. So now the basics are done. I have some curves in the model, but now I want to look if they are more or less fair. And I can check the fairness by checking the distance indicated in green, which is the local radius. For a straight curve, the local radius is 0, so you will not see the green curvature at all. And let me show you by dragging the point back and forth. Insert one, drag. If I move this about, you will see the curvature, well, changing with the position of the point. So it's very quick and easy. I said I would tell you some more about the vertices. Well, we can move the points, and you will see the vertices being recalculated in the fly. That's yeah. User need not interfere with the curves, but if he would like to, you can move them about. So you can define with a few vertices the global shape of a curve, and if you're happy with it, I would advise that you would insert some further points, because the curves are automatically recalculated on every change here. So if I now press fair, everything is recalculated. You see a slight change in positions here. So the coordinates of the points are stored, and the coordinates of the vertices are simply recalculated based on all boundary conditions for this particular curve. So the positions of the coordinates and possibly tangent dependencies, either slave or manually defined. Okay, I'm not going to make the prettiest model in the world here. This is just a demo, so let's get on with that. Quite a bulbous bow. Yeah, well, there's not enough support here to define a neat shape, so I will not render this because it would look really spitting ugly. But another thing is polycurves. I can do that here. That is connect points, and if I would make a chine on that position, from here to the bow, we have a new curve. So that's quite a nice feature. I can just weave, if you like, a new curve into the model. This particular curve should be given some shape. It's a chine already because it's starting on a knuckle point. I need now to change the shape a little bit, and from experience I know you get the nicest results if I would start this at a 0, 0, 0, and at the end, well, basically that's the direction vector at the start point there, so -1, next one 1, 0, so now we have a 45-degree angle of the waterline entrance towards the bulbous bow. Well, it's a bit large, this bulbous bow, at least to my taste. As I said, I don't have a prefix plan, so I'll just do this by visual inspection, if you like. Drag this point a little bit. Bulbous bow will be quite a bit smaller there, and of course the center line, oh, that already has a slave tangent. So yeah, we're in good shape here to come up with the bulbous bow. I think this looks a bit better than what we had before. Polycurve. Yeah, some things on the properties of curves. This curve, it's the end of the flat side line, but I do like my water lines to be faired into that from the bow going off. This curve goes from, in this direction, we're looking at the right hand, the starboard side of the vessel, so this would be the right hand side of this curve. So follow me for a moment, the tangent on the left hand side will be the master and the right hand side slave, and here it would likely be vice versa. If we're running for the bottom, this is the right hand side, which will be the master, and I will show you the effect of that. Polycurve, new polycurve, a water line. Well, let's use 6, why not? Apply, close. And now this curve, even though we only have 2 intersection points found, if I start manipulating, it will have already, you can see here the little dashed yellow curve, which means a slave dependent or a dependent tangent there. So let me show you that. Selecting this curve, manipulating it a little as we did before, insert a point there, drag it around a little bit. So my waterline over the bow is depending on its neighboring part in the flat side. And if I do not do anything to that neighbor in the flat side, oops, redo, then it will be nicely fared onto the bow section. I have done that here, and I've done that for the flat bottom and for the flat side. So if I were to introduce a frame in that area somewhere, I drag it here and I will round it off nicely at 80 meters or so. Well, not 80 meters exactly. There, close. There is my first frame on the bow, and well, that doesn't look half bad. It does have a knuckle here because it intersects a knuckle line. I have complete freedom to ignore this knuckle line for this particular curve, so the knuckle will be ignored here. It's not a knuckle anymore, even though this curve will cross a knuckle line, will cross a chine. I will not have a knuckle on my frame there, and that is looking rather nice, I think. So the next one, another frame, 90 meters or so, a bit more over the bow, apply. That will have little support. It's even hollow there. That could be right, but I just don't like it, so I want to round it a little. And here, yeah, what can we do? First of all, I can define a tangent for the bottom. I may want to, well, I can have a specific idea about that, or that is a, well, I should have stored this one there, apply there. Let's save the whole thing a bit. I will get a lot of support over this area if I just interpolate a new waterline in that part. So polycurve, new planar polycurve, a waterline on, let's say 0.75, something like that. Apply, close. And you will see a, well, not so pretty waterline, but if I move the waterline by dragging a vertex, this only has a few vertices here. If it would have more, if I need more for local control over the vertices, I can insert a few, and there, well, ugly things will happen to the curve, but never mind that. I will just reset the whole thing. Or I can just start dragging the few ones that I have available. This could be right, I'm not sure. I think it's perhaps, well, it's not even bad possibly. Perhaps the bulbous bow needs to be a bit longer, but yeah, we'll see. I think that the point here is a bit wide. I will move it in, and if I have a specific dimension to work to, 3.9 meters, I can just fill it in. Now, if I were to show the shell, one moment, color opaque, display, rendering, show all shells. Then I think the color is the wrong one. Yeehaw, base color. Well, that's odd. I would expect it to render now. Oh, yeah, and it doesn't. So I will kill the graphical user interface for a moment and reopen it. Typically that would help. I don't know, we have an issue with rendering at the moment. You saw it before, but I cannot reproduce that. I hope it will in the next session actually, because it's always a trouble if you cannot show what you wanted to, which is unfortunate. Anyway, if for polycurve, further polycurves, intersection frames, I could start at 82 meters and insert a number of frames, let's say every 2 meters or so, and press apply. And now we have, well, a sort of a bulbous bow in, what is it, Not really sure, but 15 minutes or so, possibly a bit more. Anyway, I would leave it at that. It's not to show you that I can design a pretty hull form. That will take a bit longer, but a first estimate of what the thing should look like, that's quite feasible within a very limited amount of time. So that's for the demonstration on modeling. And there's more to be said on that. You can see that I've skipped a knuckle here, so this waterline doesn't have a knuckle, which it should have both here and there. Of course, this frame is not correct, so we've focused only on the bow section, not on the stern, but for the demo this should suffice. And I will of course find out why the rendering failed here, but that's something to be commented on later. Okay, that's on modeling of Fairway, the use of Fairway, and some of the most used commands. Then a model that was already done a bit further. I told you I would show you something on export of model. Clients of ours have had some comments on the output of our model into different services, and I want to elaborate on that a little. This is a model, and here suddenly rendering appears as if nothing had happened, which is nice, of course. Yeah, the shell, we've cut up the shell in different regions. So this is a region, and we have selected it for IGES export. So previously, all the gaps in the model, if you like, so if I would kill the rendering, all the parts where you can see through the model would have their own NURBS service, or their own NURBS service in IGES export, or whatever other format of NURBS services. And that was inconvenient, so we define now larger surface patches over the hull, and if I select this one, well, this one, yeah, that is, oh, I've selected the wrong, I wanted to select this one, number 3 actually, in this color. It's an IGES, and if I press preview, it will run the calculation, and these are the U and V curves we've defined or calculated for a NURBS surface patch that will match our shape. So the downside is we need to select the 4 boundaries for the NURBS surface. The upside is that we can export this to a wide range of other programs, and one of the other benefits is that the edges here are watertight. So even for 2 separate surfaces, if I would preview this one, the actual edges in between this one and that one are absolutely identical. They are watertight, and that is easy for CFD calculations for any other type of well, use of NURBS surfaces. You will not have a gap in between these two. The entire thing was already defined, so I will toss out one of these and show you how the definition is done. Close, shell, remove shell region. Well, this one, for instance, apply. Okay, I will redo that one. I don't know the number anymore, but shell, define a shell region. Well, calling everything demo today, so that's okay. Create, and now I simply need to define the contour or redefine the contour. And that is done from here. You can see in yellow which patches are connected, which part of the surface would be connected to the curves that I select now. So 5 clicks, 1, 2, 3, 4, 5. This is now my patch demo. I will select it as an IGES patch. Every 0.5 meters above a data point. Close. I need to redo that because I didn't press apply properly. In shell, define a shell region. Demo, there we go. Create, redefine 1, 2, 3, 4, 5. It's an IGES surface patch. Apply and display no shell. Edit the shell region. Demo this one. It's an IG surface patch with 0.5. If I preview that now, there you can see that again the U and V curves have been calculated for this particular one, and that's what you get. If now